Thank you guys all for joining our VeriSafe webinar with Panduit and Rumsey today. I have Zach Ganster, the product manager, and I also have Ed Lukey on. Ed Lukey was formerly with Panduit, and now he is with Synergy, but he is still a good contact to have. So with that being said, Zach and Ed, if you guys want to get started, the floor is yours.
Awesome. Well, thank you, Nicole. Today, I'm going to talk to everyone about the VeriSafe absence of voltage tester. Really, it's more or less going to be an introductory slide or introductory presentation, but I will have a lot of resources and areas to point you guys in if you want to learn more about it, and then we'll have a good amount of time for Q&A if you do have further questions. So I'm the product manager for the Prevention Through Design group here at Panduit. That group is really focused on developing active safety devices that really eliminate or take out the hazard when users are going in and interacting with different types of electrical hazards. So just a quick agenda of what we'll go through today. Just give everyone a quick background on the importance of voltage testing, do an overview of the VeriSafe AVT, and then go into what type of applications they best are suited for. And then we'll get with how to justify implementation. So if you start to either whether you're Rumsey and you're looking to how do I talk to my customers about implementing this product, or you're an actual customer looking at how do I put this into my plant floor, I'll talk through both of those use cases. Feel free to ask a lot of questions. This product is fairly technical in nature and has a lot of aspects to it. So if something doesn't quite make sense or need more clarity on things, feel free to either type in that chat box and we can address all of those at the end. So I'm going to try and get through these slides as quickly as possible to be respectful of everyone's time. So starting off with the importance of voltage testing, just to give everyone a background on electrical injuries in the workplace. What you really saw is in the early mid-90s, electrical injuries were probably double if triple the amount per year. And that was due to not having good lockout tagout programs. There wasn't a huge emphasis on electrical safety until we kind of hit the 2000s. And at that point, a lot of safety programs came about, lockout tagout came along, and electrical safety really started to improve. But what we've seen over the past decade or so is that those electrical injuries have more or less flatlined and started to increase. And when you look at these injuries, you're noticing that of all those electrical burn patients, none of those patients were following all of the safety measures. So those safety measures are putting on your PPE, they're doing the lockout tagout process, doing your live dead live test step by step, and people forget or skip steps and accidents happen. And of those injuries, so if we were looking at about 2,000 injuries per year, over half of those were actually related to electrical, or just under half of those were related to electrical incidents, that 40%. So we did a study last year of 450 safety managers and EHS professionals. And of the following past 5 years, 40% of them reported electrical incidents had occurred in their facilities. And then half of those electrical incidents were actually related specifically to voltage testing, which is what we're going to talk about today. So just to give everyone a background, some of you may have seen this, some of you may be very familiar with this, and some of you may not be. But this is kind of what happens today when an electrician, qualified worker has to go in and perform electrical work. The first thing they're going to have to do is put up those barricades and notify those affected individuals of what's going on. The second thing they got to do is isolate and de-energize their power supply. So wherever they're going to work, they go upstream, throw the disconnect, they apply their locks and tags, as you can see in the screen here. And then they'll go in and select their, inspect and find and select their personal protective equipment, or PPE. And what you can see here is he's putting on his face mask, his gloves, getting his portable tester, and going to test his tester on a known voltage source to make sure that it's functioning correctly. He's getting voltage, getting proper readings. Then he'll take that tester and test that equipment that he's going to perform work on. He's going to test it phase to phase and phase to ground. And then he's got to go back and retest that tester on a known voltage source. So what you're seeing here, a lot of different steps, a lot of different components, things required to perform this test, areas that could potentially be hazardous and areas where it's a pretty complex process. And goes without saying that these portable testers do have a lot of risk. I'm not going to spend a lot of time on this slide, but a lot of different failure modes that can occur looking at these portable testers, whether it be misinterpreting it, having damaged or improperly installed probes, human error, which I talked about, and lack of contact with conductors or ground. So this process is laid out in the NFPA 70E. So that's the process or the best practice for electrical safety in the workplace. And what it's traditionally said is when you're doing that live dead live test that we just walked through, you're supposed to be using a adequately rated portable test instrument. But in the 2018 edition, they actually added an exception that allows for personnel to use an adequately rated permanently mounted test device and permitted that it meets all of these stipulations here. But this was big and a huge shift in how electrical work is to be done. So you're changing from, you have the option now not only to use the portable, but to, in lieu of the portable, use a permanently mounted test device. So if we look at how those portable versus permanently mounted, how these would compare, this flow chart at the top here really follows what we just saw in that picture of that electrician going to do his electrical work. Comparing that to your absence of voltage testers or your permanently mounted absence of voltage testers, it's doing all of that in an automated sequence, and you're looking at the comparison 10 seconds versus 10 to 20 minutes. The other big key difference is in order to perform your live dead live test, you've got to open that panel and potentially expose yourself to hazards. With permanently mounted devices, you can actually do that without ever having to open the panel. So you're never really exposing yourself to any hazards until that absence of voltage is confirmed. So if we compare that at a more pictorial level, your traditional method, we've talked through all the PPE that's required, the portable tester, trying to find good contact to ensure that the power is de-energized. Compare that to a permanently mounted absence of voltage tester where you're simply pressing a button on the outside of the panel, verifying that absence of voltage is there, and then being able to walk in and do your work. So this leads me to the VeriSafe absence of voltage tester. This is the product that Panduit has launched in the past couple of years. It is a permanently mounted absence of voltage tester, and it's really comprised of 4 key components. You have your indicator module, which is mounted on the door. That provides you a couple of different things. First, it gives you these red LEDs to show that there's presence of voltage. So when the power is on, you're going to see your 3 red LEDs signifying your 3-phase voltage. And then when the power is turned off, those LEDs go away and you can run your absence of voltage test, and the green LED would indicate absence of voltage. This indicator module is connected to the isolation module, or the black box that you see here, via the system cable that goes out the back of the indicator module and into the isolation module. And then the sensor lead wires that are wrapped around the isolation module, those are what directly contact wherever you're testing for absence of voltage. So if we look at that in an actual pictorial installation, you kind of see the AVT indicator module on the outside of the panel, and then when you open that door, you can see the system cable going into the isolation module. This isolation module is not only the brains of the VeriSafe, but it's also keeping any hazardous voltage away from the door. So what's running on this system cable here to the indicator module is just a little bit less than 5 volts, just enough to run the test. So any hazardous voltage isn't going over the door or going to the outside of the door there. This is simplified, but there are hardwired connections for each phase and ground. The VeriSafe does have 2 connections per phase and ground, and that is for connectivity and continuity of the VeriSafe when it's testing. And we'll talk about that a little bit further, but really it allows for you to be able to be confident that it's actually connected where it's supposed to be. And if it were to ever become disconnected, it's going to let you know what's going on inside that panel. So if we walk through the operation, we've talked about the presence. So when your power is on, your red LEDs indicate that hazardous voltage is indeed present. Then you go and turn your upstream power off, those red LEDs will go away, but this does not guarantee voltage absence. I like to think of it's kind of like a stoplight. So when you have your red light, when that red light goes away and there's no lights on the stoplight, you really need to wait for that green light to know that it's safe to continue forward. So what we do is we press that test button, and that initiates the test that we talked about, where it's testing everything that a portable multimeter would be doing. Testing phase to phase, phase to ground, checking and make sure that it's installed correctly, checking itself to make sure that circuitry is still good. And then if it's under 3 volts, you're going to get a green LED and absence of voltage is confirmed. And per NFPA 70E, you're now able to go in and perform your work safely and efficiently. A common question we get is, what if I don't get the green LED? Why did my tests fail? What do I need to do? How do I need to know when to replace the battery if the test isn't working? And Panduit's come up with a list of diagnostic codes. So the VeriSafe actually has intelligence to let you know exactly what's going on inside of its system. So if you don't get the green LED, you're going to get a solid yellow triangle and then a flash code between 1 and 7, and it's going to let you know if the battery voltage is too low, if it has excess voltage on the line, if it cannot verify that it's actually been installed, or even if it has actual hardware failure, it's going to let you know it's designed to fail safe, ever fail, and then give you a green LED when it shouldn't be. So just a quick overview on a couple of the key components here. I talked to them briefly in that overview slide, but the indicator module is the first of the 4. It is mounted on the outside of the panel. You can kind of see here it uses a standard 30mm knockout, and then it comes with this cable here on the right side that allows users to know what exactly to do when they interact with this VeriSafe absence of voltage tester. The system cable is mounted, like I said, on the back side of the isolation module. It actually has a 90-degree locking connector, and that system cable is rated for 600 volts. So you can run it along higher voltage conductors if need be. And we have it in available lengths of 2 feet to up to 30 feet. So we have a couple different multiple length options for you there. With the indicator module, it actually has a lithium industrial battery that runs the VeriSafe test. It's got a lifespan of 5 to 7 years under normal operating conditions. And the key thing here is you're able to replace it from the outside of the enclosure, and you're not exposing yourself to any hazards. So this battery tray actually pulls out and completely disengages from any electrical components inside of the panel. So it is IP20 and finger safe. So if you do have a bad battery or a battery that goes dead and you aren't able to run the test, you're able to quickly replace that battery and get your positive absence of voltage indication. And then finally, we have the isolation module. This is the brains of the VeriSafe. It can be mounted via DIN rail or flush mount on the back side of the panel. And the cool thing with this isolation module that we haven't talked about yet is that it has output contacts. So on the bottom right-hand side, we designed in these functional safety rated output contacts for optional use. What these contacts do is when you get the green LED, these contacts will close and be able to send a signal to whatever you're connected to. What we really were thinking when we designed these in is access control. So think the use case of combining this VeriSafe with an electronic or lock or latch that holds the door shut. And only when you get the green LED are you able to unlock that door. So the way it's integrated is the access control kit or the access control latch is linked in with those output contacts, and it won't unlock unless you get the green LED. So it gives you an additional layer of protection, safety, and security. And we actually offer a kit, the access control kit, that does in fact do everything that we just talked about with that access control use case. So if you take a bird's eye view of the VeriSafe product offering today, we have our absence of voltage testers. There's two offerings actually. The one with the yellow faceplate is your standard VeriSafe AVT. The one with the blue faceplate is designed for hazardous locations. So if you have any Class 1 Division 2 or Class 1 Zone 2 environments, we do have a VeriSafe designed for that. Then we also have the access control kit. It's one of many electronic latches that can work with the VeriSafe output contacts. This one, it has been designed to not only integrate the electronic latch, but also integrate a mechanical override if you do need to perform live work for whatever reason, or the VeriSafe isn't giving you the green LED when you expect it to. Panduit's also developed and designed a couple of connectivity enhancements. So these are the insulation piercing connectors. These are custom made for the VeriSafe. Like I said earlier, it has 2 sensor leads per phase. What these insulation piercing connectors do is allow you to, it has 2 separate ports for each sensor lead and allows you to make 1 connection per phase and simplify your installation time. Talked about the different system cables if you do require a different length. And then finally, we also have a retrofit enclosure. So what this is an 8-inch by 8-inch box that has the VeriSafe pre-installed. So if you have an application where you may not have room in your existing equipment or not able to punch a 30mm hole for the indicator module, the retrofit enclosure is a great option where you can install it next to your equipment, run a piece of conduit into it, and actively or accurately be able to perform your absence of voltage test. So a lot of times we've talked about the portable, the typical multimeter, and we talked about the VeriSafe. We still get a lot of pushback on, hey, I still trust my meter. And this is a really good comparison to show people of comparing the typical multimeter on the market today to a permanently installed absence of voltage tester or VeriSafe. So the first thing is I can see what I'm testing. Can you always see what you're testing with a typical multimeter? A lot of times you're exposing yourself to hazards, and the conductors that you're trying to test for may not actively be exposed. So you may be touching on paint or a barrier that you're reading 0 volts, but in fact it's actually still live. With the VeriSafe, you're hardwired into those conductors. It's a part of every single test, so you know that you're connected every single test. With the functionality test, it's really doing the same thing, the live dead live test. VeriSafe's doing the same thing with that's built-in known voltage source and giving you really that same functionality test. Voltage rating for VeriSafe is up to 600 volt. And our overvoltage category, we do have a Cat 3 and Cat 4. Really, Category 3 is where a vast majority of our applications are at this time. From a UL listing perspective, the permanently mounted AVTs are actually required to meet the same UL listings that a typical voltmeter would have to meet today. And in addition to that, we're required to meet UL 1436, which is for permanently mounted absence of voltage testers, and VeriSafe also has a UL 508A rating. And in addition to all of that, the VeriSafe has a SIL 3 functional safety rating. What that means is that it has redundant circuitry in its system and will fail safe most of the time. The numbers are in our user manual, and I won't get into the math here, but if you equate this functional safety rating to its test and it checks for hazardous failures, you could press that test button and not get a hazardous failure for over 10,000 years. So when I'm looking at a high level features and benefits for the VeriSafe absence of voltage tester, these are the things I'm going to be looking at. So it's giving me improved safety and risk reduction by being permanently mounted, being able to run that test from outside of the door. It's giving me reliable results with that SIL 3 functional safety rating being hardwired into where I'm testing for absence of voltage. So I know I'm getting the same test every single time I'm going into that panel. It's increasing my productivity, comparing that 10 to 20 minute time frame for the traditional process, comparing that to 10 seconds of being able to run that test on the outside of the panel, get in, perform my work quickly, safely. It's simplifying the process. So instead of having to remember every single step in that process we laid out at the beginning of this presentation, you're now able to simply press a button and it's doing all of those steps for you. And then it's also got a lot of different flexible applications, and we'll talk about some of the applications in the coming slides here. So before I go any further, I do want to make note of this, and since we don't have time to really dive into all of these, I just want to call this out, that it's really important when you're looking at permanently mounted products on the market today, that the terminology really does matter. So traditional products like voltage indicators and voltage portals and analog or digital panel meters may appear that they do very similar functionality to the VeriSafe absence of voltage tester. In reality, it does not, and it's very important that you look for that UL 1436 rating when you're evaluating these permanently mounted products for that absence of voltage test. We have a lot of collateral on this, and if you want to dig deeper or using other products today, we've got three key pieces of documentation here. First one is a white paper on showing the different permanently mounted voltage testing products on the market today, the myths, the differences, and the benefits of each. So it really is a good unbiased approach to how these products should be used in the market based on what the standards are saying and what best practices are saying. The second one is really around, should test portals be used for absence of voltage testing? Something that's become a little bit more on the radar for companies today, and looking at that and making sure that that makes sense. And then we also have a grounding failure case study comparing these three products. This actually came from a customer of ours that was evaluating all of the products side by side, and this is what won them over to VeriSafe compared to the other products. And I'll provide links to all of these so you guys can read them at your leisure. So moving on into the AVT applications, the number one question we probably get is, where should the AVT be installed? And that we turn that around and ask a key question there. Well, where would you normally test for voltage? So the VeriSafe is to be installed at the point where you're traditionally testing with your portable meter. If it's on the line side, if it's on the load side, if it's on both sides, that's where you want to install your AVT. It's really key to note that the AVT isn't testing an entire panel, it's testing a point inside that panel. So if you have multiple test points or multiple power sources inside of a piece of equipment, multiple AVTs will be required. So key applications, if you're looking to adopt or install these are the high level ones, but by no means an all-inclusive list of applications for the VeriSafe absence of voltage tester. The first is any equipment with a single source of incoming power. Like I just talked to, if you have multiple sources of power, you need multiple AVTs, so that doesn't make it as ideal as you're having to run multiple tests. So if you have a single source of incoming power, the AVT is a really good application for that. Second is high risk associated with access. So anything that is either frequently accessed or has very high incident energy, by installing the AVT, you're running that test on the outside, and you're really reducing any sort of risk that could occur by going into those panels. Third is remote or difficult to access locations. So I like to look at this picture on the right here. of a motor control center. If you're going and having to do your portable test on the middle of that at kind of eye level, it should be fairly easy, but a lot of times these motor control centers are 6-7 feet high, and having to get up and check for absence of voltage at the very top or right along the floor can be really hard to get your meter in there and potentially unsafe. So the VeriSafe is much easier to be able to run that test from the outside of the panel. And then any sort of sites with temporary or intermittent power, if you have power outages, you really don't have with your portable tester, you don't have a power source to check that live test. But with VeriSafe, that test is done via the battery, so you don't need a separate power source to do that. And then equipment with stored electrical energy. A lot of times you'll have like a battery bank or capacitors or fans powering down. And if your voltmeter is in the AC mode, it's not going to pick up that DC voltage. With the VeriSafe, it's actually checking both AC and DC, and will let you know if there's power going down on that system. And then finally, equipment frequently serviced by third-party contractors, technicians, or machine operators. So they may not be as familiar with what's behind your equipment. So allowing them to run that test on the outside really reduces their risk. And as far as equipment with AVTs, the top three are control panels, motor control centers, or MCCs, or switchboard applications. The VeriSafe is suitable for both new equipment, for retrofitting. So you see new equipment on the right here in that switchboard example. This was actually a retrofit that a customer did of the motor control center in the middle. And then OEM installations are also another option. But really anywhere that has voltage under 600 volts, the VeriSafe is applicable for it. And just to touch on this, factory installation is available. So we've had a lot of engagement from all of the different OEMs, depending on who you're using. And so if we walk through these, like Rockwell Automation has it on their fast track program. Eaton is pre-installing these on a lot of different pieces of equipment, as well as Schneider Electric, but they really all can do engineer to order type installations with this device. And if you do want to learn more on the applications and where can I actually install this VeriSafe device, we have a couple really good documents. The first is our sensor lead connection options document. This is going to walk you through an actual installation of how can I install those sensor leads, what are best practices, what do I need to look out for, and it's got a lot of pictures showing different installations. The AVTs and motor control centers is a really good one if you're looking to adopt this in a motor control center, showing you use cases for all the different places you could install the VeriSafe. And then finally, the user manual, albeit lengthy, is full of good information on considerations when going to install the AVT. And moving into our final section on justifying the VeriSafe installation. So things to look out for when you are looking to adopt this. I know a lot of companies will say there's no price tag on safety, but a lot of times you've got to still shape that ROI and quantify, hey, this is what I want to do, but you got to be able to quantify your spend and savings. So when you're looking at creating that ROI for something like a VeriSafe, you want to look at the capital cost. So what device or material cost do I need to make the installations and any other items needed for implementation? Take into account the installation labor. So how long is it going to take me to install this, and who's going to be doing the installation? And then also look at any sort of savings, both direct and indirect. So time savings are pretty obvious one when you're looking at the two processes side by side. But other things to take into account is training simplification, being able to run that test in a much more simple process. Potential PPE reduction if you're running that test on the outside of the panel, and per your safety program, you don't have any other hazards inside that panel. You could eliminate PPE. Incident avoidance. So being able to run that test on the outside of the panel eliminates that potential for any sort of incident when they're opening and performing that live test. And then finally, insurance premium reduction. We have had customers come back to us and say, hey, we implemented this, and this has actually given us a insurance premium reduction after our inspector came in and looked at what we've done across our plant. So if we take that ROI example and we plug it in for voltage verification, so going from that portable test to a permanently mounted VeriSafe AVT, first thing we can do is look at, okay, this is just a high level, like, okay, we'll need 100 AVTs. Here's the cost of the AVT. If we need potential connectors, we can add that in here. So that would kind of pull our capital expenditures together. Then we'll look at our installation costs. So we'll say, okay, it's 100 minutes per AVT to install, and here's our installer labor rate. And then finally, we look at our operating savings. So 20 minutes for the portable tests. Here's what our typical electrician or qualified worker labor rate is, our annual average or frequency of use for that panel, and any other indirect savings, and it'll pump out a payback of 16 months. And where this calculation actually came from is something that's included in our free VeriSafe Absence of Voltage Tester app. One of the key things in that app is actually an ROI calculator, and you can walk through that, and it's going to calculate your payback period if you do want to make a switch over to a permanently mounted AVT. It's available free on the Apple Store and Google Play Store. Has a lot of other cool features as well, like a fully functional simulator of showing what that VeriSafe would do in different applications or different use cases. Has an FAQ tab and also a resources tab. So any resource that I've talked about on this call today or that we've come out with is available on this app as well. And if we're looking at the ways to adopt, this is just based on experience that we've seen with other customers. So the first thing is specifying it in new equipment. This is by far the easiest way to get VeriSafe into your plant floor, and it's so then that way it's coming in on the new equipment. Users and maintenance personnel, electricians are getting comfortable with it, and it's a clean installation. The second thing to do is retrofit in small batches. We've had a lot of customers that have used preventative maintenance schedules and gone in and just added it as part of their PM. So if they're going into a piece of equipment to do their PMs, they're bringing a VeriSafe and installing that VeriSafe while the power's down and becoming more efficient in those installs. And then the third thing we've seen people do is bulk retrofit during like something like a planned shutdown. So if a customer wants to do that, that's a really good, quick, efficient way to get it all knocked out while that planned shutdown has occurred. So you're not having to put a bump in your operations or anything like that. So with that, as we're kind of wrapping up here for next steps, just wanted to make everyone on the call aware that both Synergy with Ed and Rumsey have access to actual demo units like you see on the right here. So if you are interested in doing a demo or seeing more information on this VeriSafe product, we are able to perform those demos and set something up with a larger part of your team. We also have the ability, if you do have, hey, I want to try one of these out in my application, we're more than willing to send you guys a beta to evaluate. And then finally, we do offer a lot of technical support. I'm not naive to the fact that this is not only something that's brand new as far as a process, but it's a brand new product, and there's a lot of nuances with the device when you're going to install it. So we're here for you guys in terms of any technical support, any questions you guys may have. And Ed, I'll pass it over to you if you're off mute, and I'll let you talk a little bit to the Epson printer launch and let you touch base on that. I think you're still on mute, Ed.
How's that? Can you hear me now, Zach?
Yep, I can hear you now.
Great. Well, yeah, just to wrap our webinar up here, Nicole, thank you for putting this together for us. But Panduit has signed on board with Epson printers an agreement to come out with a few new printers for the industrial applications. We've come out with an MP100, which is that small unit in the middle that you see, which has Bluetooth connectivity and an automatic cutter and up to 1 inch with labels. It's kind of unique to the industry because you can literally use your phone with downloading 2 apps. One is a network app, one is an electrical app, and allows you to actually speak into your phone or type in whatever you want to print out. It's loaded with symbols, arrows, caution, etc. So it's a very inexpensive printer if you just want something out on the plant floor to work with. If you want to get into a more industrial mobile printer, you would work with the MP300, the one there on the left. And we've had an LS8 printer out there for years, probably 10 years or better, and it's pretty much flooded the market. That'll be around for a few more years, but this MP300 will be taking its place. It's a smaller cartridge. It has 360 dpi print resolution, so it's very clear print. Also has an automatic cutter, and it's a little faster than any of the other portable printers out there in the marketplace. You can also work with our EasyMark software with it. And on the back of that printer, that MP300, when you're ready to label a panel, you can actually drop it onto the panel. There's magnets on the back that will hold it so you can label right off the panel. And it comes with a rechargeable battery pack as well that's charging as you're using the unit. So we also have the EasyMark Plus software available that interfaces with our TDP43ME. So in the very near future, the label machines that we'll have to offer will be the MP100, the MP300, and the TDP43ME. For most of the panel shops or higher volume, we'll use the TDP43M. But just that brochure, if anybody wants a brochure, just fire an email back to Nicole, myself, or Zach, and we'll get a brochure out to you. We also demo these units, and we do a lot of conversions. We have a couple promotions out there right now where you could actually buy so many cartridges and receive a free printer. And also, if you have a Brady printer sitting around, whether it's working or not, we'll trade it in for a free printer, MP300. That's it. That wraps up my end of it. Zach, thank you very much. It may end our webinar. Nicole, if you have anything you want to add?
Thank you guys so much. Really appreciate your presentation. If anyone has any questions, you guys can feel free to stay on after the presentation and ask. If not, you guys will all be receiving an email from me just to thank you for coming to the presentation today. And it will contain a video recording of this presentation in case you guys want to go back and reference it. Or if you have a colleague who couldn't make the call today and you want to send the video their way for them to watch, that'd be great.